In part 2 of our lesson, where we write the electron configuration and magnetic properties for ions, we left off with question D. And in question D, we have the cation cobalt with a charge of 2 plus. That means it has lost 2 electrons. Let's go ahead and locate that on the periodic table. It is a transition metal, and it's found right there. Now, to make things easier for us, and since we already know how to write the electron configuration of any element, we'll use a short form, and the preceding noble gas relative to cobalt is argon. So I'll write down, and I'll show my work underneath. We have argon, and now I will write the electron configuration leading up to cobalt. Cobalt is found in the 4th row, the 4th period, and it starts off with 4s. So I'll write down 4s2. And I'm doing this as if it wasn't an ion. So I'm creating the electron configuration for cobalt itself, and then we'll consider the addition or subtraction of ions. And we have 1, 2, 3, 4, 5, 6, 7. 7 electrons in the D block. So 3d7. The reason why I wrote down 4 and then 3 in that particular order is because I'm following the diagonal rule. The diagonal rule says that first 4s is filled in, and then 3d. Technically, 3d is at a higher energy level than 4s. That being said, since this is the cation of cobalt and there's a charge of 2 plus, that means 2 electrons have been removed. So before we consider that, let's go ahead and create the orbital diagram for what we have. We have AR, we have a box that represents this, 1 electron spinning up, 1 spinning down. And for this, we'll have 5 boxes. So I'll create a rectangle, split into 5. 1, 1, 1, 1, and 1. These are all spinning up. And then, according to Hund's rule, they become doubly occupied. That being said, cobalt 2 plus means that 2 electrons have been removed. Now, normally, you would remove the electrons from the highest energy first, which in our case is 3d, and then the lower energy, 4s. But because it's a transition metal, we're going to be removing them from 4s before we remove them from 3d. So I'll remove these two. These become empty, and we're pretty much done. So our new electron configuration will be argon, and we have 3d7. Because we have unpaired electrons here, here, and here, this is paramagnetic. Let's move on to question E. In question E, we have to find out the electron configuration for nitrogen 3-. This means that it has gained 3 electrons. So, locating it on the periodic table, it's right there. We'll pretend as if it's not an ion. Instead, we're just working with nitrogen. Nitrogen has a preceding noble gas of helium. So I'll write down helium, and we will then write down 2s2, that orbital. It's found in the p block. This is the p block, d, s, and f. And because it's found here, after 2s, according to the diagonal rule, comes 2p. So we'll write down 2p and 1, 2, 3. Let's create the orbital diagram before we acknowledge that it has gained 3 electrons. So helium, and then a box for this orbital, up, down, and a box, 3 boxes, 1, 2, 3, up, up, and up. And now we can incorporate the 3 new electrons, spinning down, spinning down, spinning down. What you see right here represents the orbital diagram for nitrogen. Now, of course, we have to determine if it's diamagnetic or paramagnetic. There are no unpaired, so this is diamagnetic. Finally, in question F, we have calcium 2 plus. Let's see where calcium is. Calcium is right here, and the preceding noble gas is argon. And calcium will have 4s2. This is as if it were not an ion, but it is an ion, and it has actually lost 2 electrons. So drawing the diagram, AR, a box spinning up and down. This is as if it's not an ion. Removing those 2 electrons makes the box empty, and what you see here, the electron configuration for argon, is the electron configuration for calcium 2 plus. So technically it's 1s2, 2s2, 2p6, 3s2, 3p6. And there you have it. 3 more examples on how to write the electron configuration and diamagnetic properties for ions. And of course it wasn't mentioned, but this is diamagnetic.